All right, everyone, we are back and we are going to do our problem set 2 solution. So we have a mass that's 170 kilograms. Well, I'm going to change my color. Let's do that. 170 kilograms in the blue box M1. Attached to scaffold, the black rectangle attached to 2 wires. The mass of the scaffold can be ignored. So we need our coordinate system, x, y. What's our next step? We need to do our FBD, free body diagram. What's our body here? We're looking at the scaffold. So let's free the body from the surroundings. We have basically a weight here, and that weight is going to be equal to mg1, or m1g, excuse me. So it could disappear. It's not erasing. Actually, I'm going to erase the whole thing. Let me erase this. There we go. So my weight is equal to m1g. And we're going to have some force 1 here, and we're going to have some force 2 here. So 2 unknowns, so we need 2 equations. So now we need to apply our fundamental expression. So the sum of the forces, there's no force in the x, so we'll set that equal to 0, and there's no components there. Forces here, F1 plus F2 minus my weight. And let's pick a point. So let's go ahead and we'll say we have, let's draw our kind of point here, or basically, through this point here. Because we need to figure out our moment. So let's go ahead, and we're going to ignore essentially the thickness of this, the beam as well, the geometry of this. So we're going to do the moment about 1. So sum of the moments about 1 must be equal to 0. So it's going to be, if we do our right-hand rule, we're going to see that's a negative. So it's going to be a minus weight times the distance. So remember, perpendicular distance to the line of action of the force, that's going to be 3.5 meters. And then all the way on the other side, that's positive plus F2 times 11 meters. So those are 2 equations that are set up. That's going to get you some points already, but let's go ahead and solve just for fun. And you could rearrange that, but me, I like to solve it in Mathematica. I'm going to say my E1 is equal to 0. Set that equal to F1 plus F2 minus W. I'm going to define W equals, 170 times 9.8. That was our mass there. E1, equation 2 is equal to 0. Set that equal to minus W times 3.5 plus F2 times 11. And then we're going to solve E1, E2 simultaneously. And there you go. Those are our forces. Fantastic. And it kind of makes sense. Again, the weight's closer on the left-hand side, so our reaction force is larger. Excellent. So what about this problem? And this is an extra credit problem. And actually, I think we have the video for it. But let's go ahead and solve this again. We have a 20-kilogram ladder, 10 meters long, 2 surfaces with a coefficient of friction like this. What's the maximum force applied before the ladder moves? The weight acts at the same location that the force is applied. So we have y, x. So now we're going to free our body. We have right here, there's going to be a force. There's also going to be a weight that's applied here. At this location, let's see, if we're taking that the force is in that direction, let's see, because it'll slip out if we go this way, so it's going to pose. So we're going to have basically a friction mu s, and I'm going to call this my F1, because there is a reaction force at the wall, there's a reaction force 2 here, and then if it pulls like this, it wants to slip down, so it should point up. So mu s F2, mu s F1, and there we go. So let's go ahead and let's basically add up all of these different components here in our x, y, and z coordinate system. So let's do some of the forces in the x, because what do we know here? We know mu of s. We don't know f of 2. We don't know f, and we don't know f1. We know that our weight is going to be equal to our mass, which is going to be 20 kilograms times 9.8 meters squared per second. So we know that. So let's go ahead and let's figure out what we got. We're given some angles here too, so we need to be sure that we're working and actually seeing, what we have. Because our coordinate system, we're going to have it in the y and the x effectively like this. So we are going to have to break down. We're going to have to break down some of these forces in our particular system. So let's go ahead and let's get started with solving this problem. And then we're also going to have to figure out, essentially, we're going to have to pick a moment, and we want to pick the moment where we're going to kind of cancel out as many forces as we can. So that's kind of the trick to a lot of these, ladder problems and a lot of statics problems in general. We want to make our lives a little bit easier for us so that we can, save some time and save some, save some effort. So let's go ahead and we're going to set now some of the force in the x direction. So what's that going to be? Well, there's a positive F2. There's a minus mu s F1. And there's also plus this general F. Some of the forces in the y, that's going to be equal to what? Let's break it down here. So some of the forces in the y, that's going to be equal to 0. Same thing, this is going to be equal to 0. So we have mu s F2 plus F1 minus my weight. So we have how many unknowns? We have 3 unknowns. So we need one more equation. So what we have to do is we have to figure out now, we need to take essentially, pick a point around a moment, effectively, or we need to pick a origin to figure out the sum of the moments. So I'm going to pick this point. Really, any of these 3 are going to be fine because I'm going to kill out 2 of the forces that I have to deal with. So I'm going to call this moment about point A here. So if I want to sum the moments about A, set them equal to 0, I need to now look at the line of action of the force, and then I need to find out this perpendicular distance. So that perpendicular distance is going to be what? So if it's right at this kind of basically where the weight is, and it's right at that 0.5, if we look at here, this triangle looks like this. So we have a 5 length here, we have the angle, so we need this distance. So we are given essentially this theta here, and that's 36.87. So what is this distance here going to be? So I need it's going to be the cosine of this angle, right? Because cosine of theta, I'm going to call this theta 1. Cosine of theta 1 is what? It's adjacent, which is what we want, our x. That's the distance that we're trying to find, over the hypotenuse. So the distance that we want is going to be 5 cosine theta 1. So it is going to be the force times 5 cosine theta 1. And then will that be positive or negative? So if I take my finger, am I curling in that direction? The line of action is going to go like this. So if I put my finger there curling in, yep, that's going to be a positive. All right, so that's for this force here. What about this force here? So the line of action now, that's going to be this distance. So I need to calculate this particular distance now from the line of action of my weight. So what is that particular distance? Well, that's going to be this length of my triangle, effectively, right? Because if we look at it, this distance should be exactly the same. So what is that? That's going to be the sine. And you see here, I'm going to have to switch my hand angle for that. So that is going to be minus W times 5 times sine cosine, or sine of theta 1. And theta 1 is just at 36.78. Whew, we got that. What about this one? So now I'm going to have another minus mu s f1 because I'm going to have to turn the other direction. The line of action, the perpendicular distance, is going to be that full length here. And what is that? Well, that's just already given to us here. We can see it's just an 8 times our distance is just the 8 right here because it's going from here to here. That's our perpendicular distance from the line of action. And then from here to here, for F1, that's going to be a positive F1. And what's the perpendicular distance from the line of action? That's just going to be the 6 meters. And then set all that equal to 0. 3 equations, 3 unknowns. Let's figure it out. So let's go ahead. I'm going to say my I'm going to say EQ1 is going to be equal to, I'll just say f of x equals 0 equals f2. And actually, let's do ahead. What is it? 20 kilogram. My weight equals 20 times 9.8. So we're going to do f2 minus, and what was our mu s1? Mu s is equal to 0.4. Mu s equals 0.4. f2 minus mu s times f1 plus f, set that equal, and that's already set equal to 0. My fy equals 0, set it equal to mu s times f2 plus f1 minus w. And then moment of A equals 0, set it equal to f times cosine of, what's my angle here? 36.87 degrees. Exactly. Minus w times 5, and I think there's a 5 here too. I'm missing 5. Minus w times 5 times sine of 36.87 degree. And then finally, what was that? Was that a minus? Yeah. Minus mu s times f1, or was that f1 or f2? F1, yeah. f1 plus f1, and actually times 8, plus f1 times 6. Solve fx, fy, ma. And we got our answers. F1, F2, we got it. Fantastic. So, we will see you in the next video. Thanks. Bye.